Hi, welcome back. My name is Attila Börös. This is the fifth lesson in our solar energy course. In the previous chapters, we learned about the sun, the sunlight, its effects, and in the last one about the history of using solar energy. Now we will check what can we do with the solar energy. I will talk about the methods for using solar thermal energy, active or passive energy usage, different types of solar energy collectors, and water and air heating applications. So, why solar energy then? Solar thermal energy is one of the most cost-effective forms of green energy. The fact that the sun is the most plentiful source of energy on the entire globe and that it could be one day the most reliant source of energy. As you see, more solar energy hits the Earth in 1 hour than all of the humanity consumes in a year. Traditionally, the world's electrical needs have been fulfilled by fossil fuels like oil, natural gas, and coal. However, these energy sources have two main negative impacts. They play a bigger role in global warming and acid rain pollution, which negatively impacts many animals, plants, and humans in the environment. Few countries have full access to fossil fuel-based energy resources, which can lead to global political and economical instability. The best alternative is solar energy, which is a renewable resource, meaning it will not become unavailable at least for a more 5 billion years. It provides an unlimited, steady supply through time. Solar energy is also a green source of energy because it does not emit pollutants during the energy production process. What are the possibilities to use the solar energy? It is actually energy harnessed from the sun. It is harnessed in two main ways. First, through the production of heat, this is our daily topic, and through the production of electricity. So, what is the difference between solar thermal energy and solar PV energy conversion? First, let's see the left column, the solar thermal energy conversion. It heats water and living spaces. Solar thermal energy is indirect method of power conversion. It is used to heat up some fluid to generate mechanical power, which in turn produces electricity. However, mostly we use it directly, requiring only the heat. It has been used throughout time and it is more economical than PV conversion. Now, on the right side, PV energy conversion. It produces electricity directly. Solar PV energy is the direct conversion of solar radiant energy into electrical energy. It uses the photovoltaic effect. This happens due to excitation of the electron and hole pairs when the light falls on it. It is a direct method of energy conversion. There are plenty of methods for using solar thermal energy. First of all, we can separate the home and the industrial applications. Home applications are the solar space heating, the solar water heating, the pool heating, the greenhouse production, passive house heating, and solar cooking. The industrial usage. Technologies using concentrated solar power are the parabolic tube, dish Stirling, solar power tower, Fresnel refractor. The concentrated solar power plants utilize the more complex collectors to produce electricity by heating a liquid to turn a turbine connected to a generator. I will talk about them in the next video. Solar energy can be broadly categorized as active or passive solar energy, depending on how they are captured and utilized. In active solar energy, special solar heating equipment is used to convert solar energy to heat energy, whereas in passive solar energy, the mechanical equipment is not present. Active solar systems include the use of mechanical equipment like photovoltaic cells, solar thermal collectors, pumps and fans to trap and transport solar energy. Passive solar technologies convert solar energy to heat energy without the use of active mechanical systems. It is mainly the practice of using windows, walls, trees, building placement, and other simple techniques to capture or deflect the sun for use. Passive solar heating is a great way to conserve energy and maximizing utilization. An example of passive solar heating is what happens to your car on a hot summer day, or easily a greenhouse. Because it is an important issue, you will see about this topic a whole video later in this course. Solar energy collectors are the basics of any solar system. They are actually heat changers, so it captures the radiant energy from the sun and converts it into heat. But how does a solar collector convert solar energy into heat? By taking advantage of a process known as the greenhouse effect. The basic idea is that the solar energy passes through a layer of glazed glass where it is absorbed by the underlying material. So solar energy excites the molecules in the underlying material, resulting in heat. The glazing of the glass prevents the heat from escaping, thereby effectively capturing the heat, like what happens in the Earth's atmosphere. Once the heat is captured, we can put it to good use, but in order to use it, you first need to understand some of the basic principles of heat. Basic principles of heat. What is heat actually? Heat is simply a form of energy associated with the motion of molecules. When the electromagnetic waves coming from the sun hit an object, they excite the molecules of the object, causing them to move. This molecular movement is heat. Heat is always moving from a higher to lower temperatures until the temperature differences are equalized. This is known as heat transfer. If you place two objects next to each other, the warmer object will cool down as its heat is transferred to the cooler object. The cooler object, in turn, will warm up. Heat transfer is driven by the difference in temperature of the objects. The heat transfer rate is proportional to the difference in temperature. Basically, the larger the difference in temperature between the objects, the faster the heat moves. One of the causes of an interesting phenomenon, the Pemba effect. If you take two similar containers with equal volumes of water, one at 35 degrees Celsius and the other at 100 degrees Celsius, and put them into a freezer, one that started at 100 degrees Celsius freezes first. It is interesting, and to be honest, scientists cannot give a complete explanation about this. To really understand solar thermal energy, you need to understand the ways of heat movement. This is especially important for passive solar energy applications, but actually in all solar setups. There are three basic physical ways that heat moves: the convection, conduction, and radiation. We will talk about them in detail. The rate of heat energy flow depends on the temperature difference between the two sides. Do you remember the previous slide with the Pemba effect? Here, in the right bottom corner the difference between the two sides of the window. The total area available for the flow, actually the surface area, for example, a window. The wall has normally a better insulation capacity, so the bigger the glass surface, the higher the loss of the heat and the insulating qualities of the material. So first we talk about the convection. It is the transfer of heat through a solid material or from one material to another where their surfaces are touching. Heat is conducted more easily through a solid material than through layers of material, even when the layers are held together tightly. This is important as the conduction of a heat through building materials like walls is a major source of heat loss. In other terms, if you put a pot of water to boil on the hob and a little later you touch it, you will understand conduction. Convection is the transfer of heat by a moving fluid, usually air or water. Natural convection is caused by the heating and cooling of the air in a room as it contacts objects. As air is warmed up, it expands, resulting in having a lower density than the cooler air around it. Since the density is lower than the cool air, it will rise. As the air cools, its density increases and it will sink again, starting the process all over again. This movement of air is known as a convectional current. The birds and glider pilots love this heat movement. When the air is getting warmer than in surroundings, for example, a bare soil next to a forest, do you remember this? This is the albedo. The dark area warms up faster, so the air will rise, sometimes with 6 to 7 meters per second, and the birds and glider pilots can ride on it. In other terms, with the aid of solar energy, they can increase their positional energy, and positional energy can convert into kinetic energy. Like this, without engine or wing movement, they are able to fly a lot of time and cover even hundreds of kilometers. Radiation is the direct transfer of heat through space by electromagnetic waves coming from a warmer object to a cooler object. Heat radiates in all directions from a warm material and will warm all surfaces that are in direct line of sight of the material. Most objects that block visible light will also block radiant energy. You have experienced this when you move into the shade on a hot summer day to cool down. You are moving out of the direct line of sight of the sun's radiant energy, and as a result, you get cooler. In the first chapters, we were talking about it. Actually, this is the way how the solar energy reaches the Earth. It is quiz time. Do you remember what are the three basic physical ways that heat moves? Conduction, where the surfaces are in touch. Convection, where the air is transferred by a moving fluid or air. And radiation, like the heat energy is reaching the Earth. So, after understanding the heat and its movement possibilities, let's have a look at the active ways in using it. This is a schematic sketch drawing of an active solar heating system. These are comprised of collectors, distribution systems, and storage devices. And how does active solar heating system operate? The flat plate collectors are usually placed on the roof or ground in the sunlight. The top of or the sunny side has a glass or a plastic cover to let the solar energy in. The inside space is black, absorbing material actually, to maximize the absorption of the solar energy. The cold water is drawn from the storage tank by a pump tube and is pumped through the flat plate collector mounted on the roof of the house. The water absorbs the solar energy and it returns back to the tank. In the storage device, the warm water warms up by conduction the heating material, which is circulating in a separate line. Warm water or other heating fluid from the tank is pumped through the heating coil. It can be radiators, floor heating, and so on. The heating material loses its heat by conduction and convection, and the cold heating fluid returns to the heat exchanger, and the cycle goes on. The solar collector is the most important part of the system, so we will talk about it a lot. According to the achievable temperature, the solar thermal energy is classified as low temperature solar collectors. Their temperature is below 100 degrees Celsius. Medium temperature solar collectors, where the temperature is from 100 to 300 degrees Celsius, and high temperature solar collectors, where the temperature is above 300 degrees Celsius. We will talk about all three categories in detail. The first category, the low temperature solar collectors, are the most important for daily users. These are the most common, easily accessible devices, which helps people to exploit the solar heat energy. Low temperature solar collectors use non-concentrated light. These are used in water and space heating, food drying, and pool heating applications. Low temperature heat collectors have the following types: flat plate collectors and evacuated solar collectors. First of all, I will explain the flat plate collectors with you. These are the most common types. The flat plate collectors forms the heat of any solar energy collection system designed for operation in the low temperature range from ambient to 60, or the medium temperature range from ambient to 100 degrees Celsius. A well-engineered flat plate collector delivers heat at a relatively low cost for a long duration. The flat plate collector is basically a heat exchanger which transfers the radiant energy of the incident sunlight to the heat of liquid or air. The term flat plate is slightly misleading in the sense that the surface may not be truly flat. It may be a combination of flat, grooved, or of other shapes as the absorbing surface with some kind of heat removal device like tubes or channels. Flat plate collectors is used to convert as much solar radiation as possible into heat at the highest attainable temperature with the lowest possible investment in material and labor. Flat plate collectors have the following advantage over other types of solar energy collectors: absorb direct, diffuse, and also reflected components of solar radiation, are fixed in tilt and orientation, and thus there is no needed for tracking the sun, are easy to make and are low in cost, have comparatively low maintenance costs and long life, and finally, operate at comparatively high efficiency. There are different flat plate collector types. In this slide, I collected them. As I said before, the solar heating system can operate with heated fluid or with air. According to this, we can divide the systems. The two main categories can be more subdivided, but the exact structure of the pipes in the collectors is beyond this course, so I just mentioned them. Type 1, pipe and fin type, in which the fluid flows only in the pipe and hence has comparatively low wetted area and liquid capacity. Type 2, rectangular or cylindrical full sandwich type, in which both the wetted area and the water capacity are high. And the type 3, roll-on type or semi-sandwich type, is intermediate between types 1 and types 2. The best choice of collector panel depends on the particular application. For low temperature requirements, such as in warming swimming pools, the plastic full water sandwich panel may be the most appropriate choice. For domestic and industrial applications, higher temperatures are required and therefore higher efficiency, reliability, and long life are the main characteristics required. For such applications, pipe and fin type panel may be more suitable. The air heaters can be also divided into subcategories like fin plate, metal matrix like the cooler radiator in the cab, and coregulated plate. As you see, this type of collectors were used already a good 100 years ago. This photograph was taken in 1906. The basic configuration of a common collector can be seen in the next slide. So, what are the components of liquid flat plate collector? Cover or glazing, which may be one or more sheets of glass or other terminus radiation transmitting material, for example polycarbonate, for reducing heat loss. Then, inside, tubes, pins, or passages for conducting or directing the heat transfer fluid from the inlet to the outlet. A heat transport fluid to remove a heat from the absorber. Black absorber plate, which may be flat, corrugated, or grooved with tubes, fins, or passages attached to it. It can be metal or plastic. Insulation, which minimizes heat loss from the back and sides of the collector. And container or casing, which surrounds the various components and protects them from dust, moisture, etc. Principle of flat plate collectors. Now let's talk about the principle of the flat plate collectors. The principle behind the flat plate collector is simple. If a metal sheet is exposed to solar radiation, the temperature will rise until the rate at which energy is received is equal to the rate at which heat is lost from the plate. This temperature is termed as the equilibrium temperature. If the back of the plate is protected by a heat-insulating material and the exposed surface of the plate is painted black and is covered by one or two glass sheets, then the equilibrium temperature will be much higher than that for a simple exposed sheet. The water circulating system, either by making it hollow or by smothering metal pipes to the surface and transferring the heated liquid to a tank of storage. Evacuated tube collectors. Evacuated tube heat collectors use air and vacuum as the insulating material, so the heat pipes is inside in a vacuum-sealed tube. Evacuated glass tube prevents conduction as well convection losses, because there are no physical contact. The liquid pipe floats in the vacuum like the Earth in the space. The vacuum in the tubes can be maintained for about 25 years. Due its insulation characteristics, it is the most efficient of the all low-temperature solar collectors. Other advantage of these collector types, they can operate at higher temperature with good performance than flat plate collectors, and an important feature, their efficiency is higher at low incidence angles. In other terms, wintertime, when the sun is much lower than in summer, it performs better. And these type of collectors becoming mass products, so for lower price, a more wide community can use them. thermosiphon solar water heater. In Mediterranean countries, these devices, because their simplicity and pump-free operation, that are almost on every household. It is actually a solar collector and a water tank mounted above it. No pump help needed due to the convection. How does it work? Water in the solar collector is heated by the sun and will rise to the top of the collector. Due to the closed-loop piping of the collector and the water heater, the warm water will rise to the tank, and cold water from the tank will sink towards the bottom of the solar collector. In the tank, there is a heat exchanger where the warm fluid transfers the heat to the loop, which enters the living area. This means water is starting to circulate through the solar collector and tank as long as the sun is heating the water in the collector. This system has two main advantages. They are relatively very simple, cheap, and easy to install. The lack of complex parts makes them easy to maintain. But it is also important to consider the disadvantages. Direct system without heat exchanger cannot be used in hard water areas unless a water softener is installed before the collector. They cannot be used where freezes occur unless an indirect system is installed and the storage tank is in a heated area of the building. The storage tank must be installed above the collector array, which is unsuitable in many residential settings. Did you know that 10 square meters of solar thermal panels can heat 650 liters of water daily? It is not a bad value, especially taken in consideration that the energy demands and the energy prices are continuously increasing. Solar pool heating. This is one of the most efficient way using of solar energy. Of course, you need a pool to heat it. But if you have one, it is a good idea to install it because it has a lot of advantages. The equipment has long life, minimum or no maintenance needed, simple automatic operation, extends life of conventional heating equipment, suitable for indoor and outdoor pools. Here you can see the schematic sketch drawing of a pool heating installation. You need actually a collector, a pipeline, and a pump. This basic configuration can be set up by yourself, as you see an example on the left side. It is actually a black plastic pipeline mounted on the black surface. There is no need of an extra pump because it is driven by the original filter pump. You need only to face it towards to the sun and enjoy the warm bath. Or you can see another DIY installation on the right side, the solar shower. It is quiz time again. Do you remember what is the difference between active and passive methods for using solar thermal energy? The active solar energy harvesting needs special solar heating equipment. Passive solar technologies convert solar energy to heat energy without the use of active mechanical systems. The next question, what are the components of a liquid flat plate collector? The cover, tubes, fins or passages for conducting or directing the heat transfer fluid, black absorber plate, insulation, and finally, container or casing. We will discuss today a lot of ways of converting solar energy into heat energy in the low temperature range. In the next video, we will proceed with the medium and high temperature range collectors. So see you next time. Bye.